So, what's up everyone? Ayush here. And today we're talking about something a little different. Not a new phone or a piece of hardware, but a blueprint. A roadmap. Specifically, the 4-year B.Tech Computer Science Roadmap. I get this question all the time. What should I be doing right now to get a great job after I graduate? It's a huge question, and honestly, the answer isn't just one thing. It's a series of smart, deliberate moves you make over 4 years. This video is my attempt to lay out that game plan, year by year, in a way that's actually actionable. No vague advice, just a clear path forward. The goal here isn't just to help you pass your exams. It's about building a profile that makes you genuinely industry-ready from day one. We're talking about constructing a resume that doesn't just list courses, but showcases real skills and projects. It's about being prepared for whatever path you choose, whether that's landing a top-tier job at a FAANG company, diving deep into research for higher studies, or even taking the leap and building your own startup. Each year of your degree is an opportunity, a building block. And if you stack those blocks correctly, you end up with something really solid by the end. So we're going to break it down. Year 1, Year 2, Year 3, and Year 4. For each year, we'll cover the key focus areas, the skills you should be acquiring, and the milestones you should aim to hit. Think of this as your guide to navigating the next 4 years, making sure you're not just going through the motions, but actively building your future career. So, whether you're just starting out or you're halfway through and feeling a bit lost, stick around. This is the roadmap you've been looking for. Let's get into it. Alright, so let's start with Year 1. First semester. You're fresh on campus and everything feels new. The temptation is to just focus on settling in. But this is, without a doubt, the most critical time to build your foundation. Forget advanced algorithms for a second. This is all about fundamentals. Your primary goal is to pick one programming language and go deep. Doesn't have to be the perfect one, just pick one. C++ or Java are classic choices for a reason. They teach you core concepts that are transferable everywhere. This isn't about just learning the syntax to pass a class. It's about understanding the why behind the code. How does memory work? What are pointers? Why does this loop behave this way? These are the questions that separate the great engineers from the good ones later on. Spend your first year getting incredibly comfortable with the basics: variables, data types, loops, functions, and basic object-oriented principles. This is the concrete you're pouring for the entire skyscraper you're about to build. Don't rush it. Now, let's talk about habits. Good habits started now will pay dividends for the next 4 years and beyond. The first one is coding every single day. It doesn't have to be for hours. Even 30 minutes of solving a simple problem on a platform like HackerRank or CodeChef builds muscle memory. It keeps the syntax fresh, and more importantly, it trains your brain to think logically and break down problems. It's like going to the gym. Consistency is what builds strength. The second habit is getting comfortable with your tools. Your code editor, your command line, and most importantly, Git and GitHub. Create a GitHub account on day 1. Seriously. Even if you're just pushing hello world programs, do it. Learning version control early is a superpower. It teaches you how to manage code, collaborate, and track changes. When a recruiter looks at your profile in Year 3, a GitHub history that starts in Year 1 looks incredibly impressive. It shows foresight and dedication. And don't just stick to the curriculum. The syllabus is designed to give you a baseline, but the real learning happens when you get curious. Explore. If your class is teaching C, spend a weekend playing with Python to see the difference. Read tech blogs, watch videos from other creators, and start to understand the landscape of the tech world. What are people excited about? What are the big companies working on? This context is invaluable. Your math courses are also more important than you think. Discrete mathematics, linear algebra, probability. These aren't just hurdles to clear. They are the theoretical underpinnings of everything in computer science, from cryptography to machine learning. Don't just memorize formulas. Try to understand the concepts. It will make learning advanced topics in later years so much easier. You'll thank yourself later when you're trying to understand a complex algorithm. Let's talk about a simple project for Year 1. You don't need to build a full-stack web application. A simple command line application is perfect. Maybe a text-based adventure game, a simple calculator with advanced features, or a library management system that runs in the terminal. The goal isn't to build something flashy. It's to apply everything you've learned, functions, loops, data structures, into one cohesive project. It solidifies your learning in a way that solving isolated problems can't. And while you're doing all this, start to get involved. Join the coding club at your college. Go to a workshop or a seminar, even if you don't understand half of it. The goal is to immerse yourself in the culture. You'll meet seniors who can give you advice, you'll hear about technologies you've never heard of, and you'll start to build a network. This is the beginning of your professional community. So to recap year 1, it's not about being the best, it's about being consistent. Master one language's fundamentals. Code daily to build a habit. Get your GitHub profile up and running from the get-go. Pay attention in your math classes. Build one simple, solid project that ties everything together. And start connecting with the community around you. It's a marathon, not a sprint. You are laying the groundwork. This is where you learn the alphabet before you start writing poetry. A strong foundation makes everything that comes next. The complex algorithms, the big projects, the tough interviews, significantly more manageable. You're setting up a game of dominoes. A strong push here makes the rest fall into place much more smoothly. You might feel like you're not moving fast enough compared to others, but that's okay. Depth over breadth is the mantra for year 1. It's better to know one language really, really well than to have a superficial knowledge of 5. This deep understanding is what interviewers look for and what will allow you to pick up new technologies quickly in the future. Don't neglect your communication skills either. Learn to explain what your code does in plain English. This is a skill you'll use in every interview, every team meeting, and every presentation for the rest of your career. Start practicing now by explaining concepts to your friends or writing simple documentation for your code on GitHub. So at the end of year 1, what should you have? A solid grasp of one programming language, a GitHub profile with a consistent commit history, the habit of daily coding, a foundational understanding of core CS math, and your first small project under your belt. You're not an expert yet, and that's exactly where you should be. You're ready for what's next. Alright, welcome to year 2. You've got the foundation poured, and now it's time to start building the structure. This year is all about 2 things: mastering core computer science concepts, and, crucially, starting to build things that look and feel like real software. You're moving from the theoretical to the practical. The single most important topic for this year is data structures and algorithms, or DSA. This is non-negotiable. DSA is the language of technical interviews at every major tech company. Arrays, linked lists, stacks, queues, trees, graphs, hash tables. You need to know these inside and out, but don't just learn what they are. You need to understand the trade-offs. When would you use a hash table instead of a binary search tree? What are the time and space complexity implications of your choice? This is what interviewers will grill you on. Platforms like LeetCode become your new best friend in year 2. Start with the easy problems to connect the DSA theory you're learning in class to actual coding challenges. Then, gradually move to mediums. The goal isn't to memorize solutions, it's to recognize patterns. Most algorithm problems are variations of a few core patterns. Learning to spot them is the key. Make this a consistent part of your routine. Alongside DSA, you'll be taking other core CS courses like object-oriented programming, database management systems, and maybe operating systems. Pay close attention. OOP teaches you how to structure large-scale applications. DBMS teaches you how to handle data, which is at the heart of almost every modern application. And operating systems gives you a peek under the hood of how computers actually work. These aren't just classes, they're your toolkit. Now for the fun part, development. It's time to move beyond the command line. Pick a domain that interests you. It could be web development, mobile app development, or even something like game development. Let's say you pick web development. You'll want to learn the fundamentals: HTML, CSS, and JavaScript. Then, you can move on to a framework like React, Angular, or Vue for the front end, and Node.js with Express for the back end. The key here is to build a full-stack project, not just a pretty front end, but something with a real back end and a database. Think about a simple e-commerce site, a blog platform, or a to-do list app that saves user data. This project is your first major resume piece. It demonstrates that you can do more than just solve isolated algorithm problems. You can build a complete functional product. Document it well on GitHub with a clear README file. This is also the perfect year to make your first contribution to open source. This might sound intimidating, but it doesn't have to be. Many large projects have issues labeled Good First Issue specifically for beginners. It could be as simple as fixing a typo in the documentation or fixing a minor bug. The experience is invaluable. You'll learn to read a large code base, understand contribution guidelines, and interact with other developers professionally. It's a huge plus on your resume. While you're building and learning, start thinking about your first internship. The summer after your second year is the first real opportunity for a meaningful tech internship. Your resume might feel a bit sparse right now, but that's okay. Highlight your DSA skills, your full-stack project, and any open-source contributions. Start applying early, maybe in the fall semester of your second year. Don't be afraid of rejection. It's part of the process. Apply to startups, mid-sized companies, anything to get your foot in the door. Networking becomes more active in year 2. Attend tech meetups in your city if possible. Participate actively in online communities on platforms like Discord, Twitter, or Reddit. Follow influential engineers and developers. Ask smart questions. Don't just ask for a referral. Ask about their work, what technologies they're excited about, or for feedback on your project. Build genuine connections. Let's talk about managing your time. Year 2 can feel overwhelming. You have tough courses, you're learning DSA, you're trying to build projects, and you're thinking about internships. The key is to be organized. Block out time in your calendar for specific tasks, a couple of hours for leak code, a block for project development, time for your coursework. It's a balancing act, but it's manageable with a good system. So the goal for year 2 is to transition from a student to a builder. You're solidifying your core CS knowledge, especially DSA, which is paramount. You're not just coding, you're developing. You're building a real, tangible project that you can show to people. You're dipping your toes into the world of open source and professional collaboration. And you're making your first serious attempt at landing an internship. By the end of this year, your GitHub should look much more impressive. You'll have your foundational projects from year 1, but now you'll also have a more complex, full-stack application, and maybe a few open-source contribution badges. Your resume is starting to take shape with skills, projects, and hopefully an upcoming internship. You're no longer just a beginner. This is the year of growth. It's challenging, it's demanding, but it's also incredibly rewarding. You'll start to see the pieces connect, how the data structures you learn in class are used in the database of the web app you're building. This is where the abstract becomes concrete, and you start to feel like a real software engineer. Welcome to year 3. If year 1 was about the foundation and year 2 was about building the core structure, year 3 is about, well, finishing the interiors and adding the high-tech features. This is the year you go from being a generalist to developing a specialty. It's about gaining a competitive edge that will make you stand out from the crowd during placement season. Honestly, this is arguably the most important year for your career trajectory. The first major task of year 3 is to pick a specialization. You've had a taste of different areas in year 2. Now it's time to choose 1 or maybe 2 to go deep on. The options are vast. Machine learning or AI advanced web development, maybe with microservices or DevOps, mobile development like iOS or Android, cybersecurity, cloud computing, or even something more niche like blockchain or AR/VR. Your choice should be based on genuine interest, not just hype. Once you've picked a track, immerse yourself in it. This goes way beyond your college curriculum. Take advanced online courses on platforms like Coursera or edX. If you're into AI, read research papers. Follow the experts in your chosen field. The goal is to become the go-to person among your peers for that topic. This depth is what companies look for when hiring for specialized roles. It's a massive differentiator. Now let's talk projects. Your year 2 project was great, but your year 3 project needs to be your magnum opus. This should be a substantial, complex project within your chosen specialization. If you chose machine learning, maybe you build and deploy a model that solves a real-world problem. If you're into web development, perhaps you build a full-scale application with user authentication, payments, and a scalable architecture on AWS or Google Cloud. This project is your primary talking point in interviews. It should be something you're passionate about and can talk about in great detail. You should be able to discuss the technical challenges you faced, the architectural decisions you made, and what you would do differently. A well-documented complex project on your GitHub is worth more than a dozen small generic ones. It's your proof of work. Year 3 is prime time for internships. The summer after your 3rd year is the most critical internship you will do. This is the one that very often converts into a full-time offer, or PPO. You need to start preparing and applying for these internships in the fall of your 3rd year. Target the companies you want to work for post-graduation. Your resume is much stronger now, with core skills, advanced projects, and possibly a previous internship. To land these top internships, your DSA skills need to be razor sharp. You should be comfortably solving LeetCode mediums and have a good handle on hard-level problems. In addition to DSA, you'll start facing questions on system design, especially for more senior intern roles. Start learning the basics of system design. How would you design Twitter, Uber, or a URL shortener? There are great resources online for this. It shows a different level of thinking. Beyond technical skills, it's time to build your professional brand. Clean up your online presence. Create a polished LinkedIn profile that details your skills, projects, and experiences. Consider starting a professional blog or a personal portfolio website. Write about what you're learning, document your project journey, or share tutorials. This positions you as an expert and shows initiative. Recruiters actively look at these things. Participate in hackathons. This is a fantastic way to build something cool in a short amount of time, work in a team under pressure, and network with sponsors and other participants. Winning is great, but even just participating and having a project to show for it is a valuable experience and another great addition to your resume. It demonstrates passion and the ability to deliver. While you're deep in your specialization, don't forget to keep your fundamentals sharp. Continue to practice DSA problems, even if it's just a few a week. Technology changes, but the principles of good software engineering and efficient algorithms are timeless. This continuous practice will keep you ready for any interview that comes your way, even if it's outside your core specialization. Think about research opportunities as well. If you're leaning towards higher studies, like a master's or PhD, working on a research paper with a professor is invaluable. It shows you can handle unstructured problems, conduct literature reviews, and contribute to the body of knowledge. This is a completely different skill set from development and is highly valued in academia and industrial R&D labs. So, to summarize year 3, it's about depth over breadth. You choose a specialization and go all in. You build a significant, impressive project in that domain. You secure a high-impact internship for the summer. You sharpen your advanced DSA and system design skills. You build a professional online brand, and you explore opportunities like hackathons and research that give you that extra edge. By the end of year 3, you should have a clear career direction. Your resume should be packed with evidence of your skills, advanced coursework, a major project, a top-tier internship, and maybe even publications or hackathon wins. You're not just a student anymore. You're a young professional with a specialty. You're ready for the final leg of the journey. This is the year of acceleration. You're building on the momentum from the first 2 years and hitting top speed. The work you do in year 3 will directly determine the quality of opportunities you have in year 4. It's intense, but the payoff is huge. You're essentially building the case for why a top company or graduate school should choose you. And that brings us to year 4, the final boss. This year is all about one thing: converting the last 3 years of hard work into a tangible outcome. Whether that's a job offer, an admission for higher studies, or a plan for your startup, this is the launchpad. The focus shifts from learning and building to preparing and executing. The placement season is here. Your first priority is placement preparation, and it should start the moment you enter your final year. This is a full-time effort. Your resume and portfolio should be finalized. Get them reviewed by seniors, professors, and career services. Every bullet point should be impactful, using action verbs and quantifying your achievements wherever possible. For example, instead of saying worked on a website, use developed a full-stack e-commerce platform, resulting in a 15% increase in user engagement. Now, it's all about interview prep. You should be living and breathing DSA and system design. Do mock interviews, as many as you can, with friends, with seniors, or using online platforms that pair you with other engineers. The goal is to get comfortable articulating your thought process under pressure. It's not enough to know the answer. You have to communicate how you got there. This is a skill, and it needs practice. Beyond the technical rounds, prepare for the behavioral interviews. Companies want to know if you're a good fit for their team and culture. Prepare stories using the STAR method: situation, task, action, result. For common questions like, tell me about a time you had a conflict with a team member, or describe a challenging project. Have these stories ready. They show self-awareness and professionalism. If your goal is higher studies, your focus will be slightly different. Your applications, including your statement of purpose, letters of recommendation, and GRE scores, should have been in the works. Your final year project becomes a cornerstone of your application, especially if it's research-oriented. You'll be spending time refining your SOP to tell a compelling story about why you want to pursue research in a specific field at a particular university. For the aspiring entrepreneurs, Year 4 is about validation and planning. You've likely identified a problem and have a prototype or MVP from your Year 3 project. Now is the time to talk to potential users, get feedback, and refine your idea. You'll be learning about business models, market research, and funding. Your final year can be an incubator for your startup, often with support from your university's entrepreneurship cell. Don't neglect your final year projects and coursework. It can be tempting to focus solely on placements, but finishing strong academically is important. It shows commitment and discipline. Plus, your final year project is your last chance to add a major piece to your portfolio before you graduate. Make it count. It could be the very thing that tips the scales in a close interview decision. This is also a time for reflection and decision-making. You might get multiple offers. How do you choose? It's not just about the salary. Think about the role, the team, the company culture, the learning opportunities, and your long-term career goals. Talk to people who work at those companies. Make an informed decision that sets you up for success in the next 5 years, not just the next one. Networking continues to be crucial. Reach out to alumni from your college who are working at your target companies. They can offer valuable insights, and in some cases, a referral can make a huge difference in getting your resume seen by a recruiter. Be professional and respectful of their time. A well-crafted message is more likely to get a response than a generic "can you refer me?" As you go through interviews, remember that every single one is a learning experience, especially the rejections. If you get rejected, try to get feedback if possible. If not, reflect on what you could have done better. Was it a specific DSA topic? Was it your communication? Use every failure as data to improve for the next one. Resilience is key during this period. So, the game plan for year 4 is execution. You're polishing your resume and portfolio to perfection. You're doing mock interviews until you can solve problems and explain your thought process in your sleep. You're preparing for behavioral questions. You're making a strategic choice based on your career path, be it placements, higher studies, or entrepreneurship, and you're finishing your degree strong. By the time you walk across that graduation stage, you should have a plan. You'll have an offer letter in hand, an acceptance letter from a university, or a solid business plan for your startup. This is the culmination of 4 years of dedicated strategic effort. It's the moment the rocket leaves the launch pad. The final year is a pressure cooker, there's no doubt about it. But you've spent 3 years building the skills, the projects, and the mindset to handle it. Trust the process, stay organized, and focus on the execution. You've done the hard work to get here. Now it's time to cross the finish line. So, that's the 4-year game plan. But before we wrap up, I want to leave you with a few bonus tips that weave through all 4 years. First, communication is a superpower. Learn to write well, speak clearly, and present your ideas effectively. Second, network intelligently. Build genuine relationships, not just a list of contacts. Third, read. Read books like Cracking the Coding Interview, but also Clean Code and The Pragmatic Programmer. These will shape how you think. And finally, be a part of a community. Give back by mentoring juniors or contributing to discussions. Your project portfolio is your proof, but these soft skills are what will accelerate your career long-term. If you follow this roadmap, focusing on fundamentals in year 1, building core skills and projects in year 2, specializing in year 3, and executing in year 4, you'll be in an incredibly strong position. You'll have a solid foundation in DSA, a portfolio of impressive projects, real-world internship experience, and the confidence to ace interviews. You'll be ready for a top job at a FAANG company, a challenging role at a fast-growing startup, or a spot in a prestigious master's or PhD program. You've built the complete package. This roadmap is a guide, not a rigid set of rules. Your journey will be unique. So, to help with that, I'm thinking of creating a tool on my website where you can input your goals, whether it's AI, web dev, or research. And it will generate a customized, printable version of this roadmap just for you. Let me know in the comments if that's something you'd find useful. The goal is to make this as actionable as possible for you. Thanks for watching, and I'll see you in the next one.